Imagine looking up at the night sky and knowing that somewhere out there, a massive visitor is hurtling straight toward our solar system. It isn't like any meteor or comet you've ever heard of. This thing is larger than Manhattan, weighs tens of billions of tons, glows in places that should be dark, and follows an orbit so strange it makes scientists frown in confusion. They've named it 3I Atlas, the third interstellar visitor humanity has ever discovered. But here's the unsettling part. It might not leave. On October 29th, when Atlas swings closest to the sun, Earth just happens to be on the exact opposite side, which means, in that decisive moment, we'll be completely hidden from view. And that would be the perfect opportunity if Atlas were planning to do something we weren't meant to see. Harvard professor Avi Loeb believes these coincidences are anything but random. In this video, we'll break down the evidence, its size, its mass, its orbit, and that eerie blue glow to answer the question, is 3I Atlas really just a comet or something else sent by an alien civilization? Out in the vast emptiness of space, from time to time, visitors arrive from far beyond, slipping past our small solar system before vanishing again, as if they were only stopping by in the blink of a cosmic eye. Astronomers call them interstellar visitors, travelers between the stars. And before Atlas appeared, we had already encountered two remarkable guests. The first bore a poetic name, Oumuamua, discovered in 2017. In Hawaiian, the word means a messenger from afar, a phrase that sounds like an echo from an ancient culture sensing the weight of the moment. When telescopes first captured faint glimpses of Oumuamua, scientists were puzzled. It wasn't a comet, for it carried no shimmering tail. It wasn't an asteroid either, since its trajectory was beyond the sun's gravitational grasp. Oumuamua spun through space like a dry leaf caught in the wind, about 100 meters long, small but unpredictable. As it drifted away, it accelerated ever so slightly, as if nudged by an invisible hand, then disappeared into the interstellar dark. Imagine standing on a hill that night, watching a point of light streak by before dissolving into the void. It would feel like witnessing a secret traveler leaving footprints on the sand and vanishing without a word. That was Oumuamua. Tiny, mysterious, tailless, forever leaving us to wonder. What was it? 2 years later, in 2019, the second visitor arrived, named Borisov. Unlike the strange and elusive Oumuamua, Borisov felt more familiar, like meeting someone from a dream you've had before. It was a classic comet, small, fragile, leaving behind a delicate tail stretching through space. Borisov was full of ice and dust, just like the hundreds of thousands of comets we've studied within our own solar system. If Oumuamua was the enigmatic wanderer who left us with questions, Borisov was the gentle guest, carrying an old story about frozen relics born in the distant, frigid reaches around another star, only to be cast out into the void. Watching Borisov brought a kind of reassurance, a reminder that amid all the strangeness, the universe still follows familiar patterns. Then, in 2025, the third visitor appeared. They named it Atlas, and from the very beginning, it stunned the astronomical community. If Oumuamua was a mysterious pebble, and Borisov a familiar shard of ice, Atlas was a mountain drifting across an ocean. Early estimates put its size at nearly 20 kilometers, larger than the island of Manhattan. Though later revisions scaled that number down, it still dwarfed its predecessors, outshining them in both mass and brilliance. Even from the distant orbit of Jupiter, still cold and remote, Atlas blazed like a headlight, while most comets lay dormant beneath their icy shells. It approached the solar system like a giant guest, silent yet radiating a light so intense it demanded to be noticed. Close your eyes and picture them as three characters stepping onto an ancient stage. First, Oumuamua, cloaked in mystery, passing by in silence and leaving behind unanswered riddles. Then Borisov, gentle, wrapped in a frost-laden shawl, smiling before departing, reassuring us that part of the cosmos still makes sense. Finally, Atlas, towering, monumental, like an ancient warrior arriving with an unnatural glow, making us wonder, why now, and will it leave, or stay? Three visitors, three forms, three stories, each like a doorway into the endless diversity of the interstellar realm. And in the stillness of night, as imagination takes flight, it's hard not to ask, did they come with purpose, or are they simply accidents of cosmic chance? We welcomed both Oumuamua and Borisov, each bearing their own tale. And now, as Atlas enters, so different, so immense, the questions deepen. It's no longer just what is it, but also why now? To begin answering, we must look closely at Atlas's peculiar traits, starting with its staggering size, large enough to shake the very foundations of our probabilities. If Oumuamua was like a dry leaf spinning in the wind, and Borisov a familiar shard of ice drifting quietly in the dark, then Atlas felt completely different, as if an entire island were gliding silently across the cosmic ocean. From the very first measurements, scientists were stunned. Early estimates put its length at nearly 20 kilometers, big enough to cover the whole of Manhattan if laid on Earth's map. Later, those numbers were revised down, closer to 5 or 6 kilometers, but even then, it dwarfed the other interstellar visitors we've encountered. Close your eyes for a moment and picture a mountain drifting through the night sky among glittering stars, and you'll get a sense of the awe Atlas inspires. But size was only the beginning of what made it extraordinary. Calculations of its mass delivered a staggering number, at least 33 billion tons, millions of times heavier than the largest ships humanity has ever built. To put it in perspective, if you could drop Atlas into a lake, it wouldn't just sink. It would feel as though it dragged the very sky down with it. And yet, despite its colossal weight, it moved with surprising grace, slipping through the solar system without hesitation, like a giant dancer keeping perfect rhythm. Stranger still, unlike most comets, its enormous mass didn't seem to be pushed around by the jets of gas streaming off its sunlit surface. While other comets jitter and veer, sneezing their way through space, Atlas held its steady, unhurried stride. When scientists turned to study its composition, the mystery only deepened. A typical comet, made of water ice, dust, and rock, releases great clouds of vapor as it nears the sun. Atlas, however, told a different story. It carried far more carbon dioxide than water, about 8 times as much, a rare ratio. Imagine a guest arriving at the solar system's banquet table, carrying a flavor unlike anything we've tasted before. The CO2 it released wrapped it in a transparent veil of gas, strange and elusive, like a passing scent that makes you stop and wonder where it came from. And then there was the green light, eerie and unexpected. Molecules like C2 or cyanide can glow that color, but the way it flared from Atlas caught observers off guard. As if someone had suddenly flipped a switch, a green halo spread outward, cold and breathtakingly beautiful. Picture standing atop a mountain on a moonless night and seeing it in the sky, glowing like a ghostly dance, a lantern hung in the vastness above. For a fleeting moment, it transformed the universe into a stage, and Atlas into the performer of a private, otherworldly show. Piece by piece, its story came together, its massive size, immense weight, peculiar chemistry, and haunting glow, all painting a portrait that refused to fit neatly into any category. Atlas was a comet, yet not entirely. It carried the breath of distant worlds, while hinting at something more intricate, more mysterious. To scientists, it felt both familiar and alien, like seeing a face you half remember from a dream. Perhaps that's what makes Atlas so captivating. It isn't just a wandering block of ice, but a riddle, a doorway to the possibility that we don't yet fully understand how the cosmos works. In every speck of dust, every molecule of gas it shed, it whispered that there are still secrets waiting to be uncovered. And yet, all of this was just the surface. The part that lingered in scientists' minds wasn't only its size, its weight, or its glow, but the way it moved. Unlike the tangled paths traced by millions of other celestial bodies, Atlas's orbit seemed almost deliberate, as if sketched with a careful hand. To truly grasp what that means, we have to follow its story further, into a place where things grow stranger, as though someone or something had fine-tuned the course of this interstellar giant. There are moments in the long journey of a celestial body that feel almost fated, like a wandering traveler arriving at a crossroads where every possible turn could change the rest of their life. For Atlas, that moment came on October 29th, the day it reached its closest point to the sun. Astronomers call this perihelion, the place where the sun's heat and light strike with their greatest force, where the frozen silence of space is replaced by the fierce blaze of our central star. If you imagine yourself as a tiny dust grain drifting alongside Atlas, the experience would feel like passing through a giant forge. The closer it draws, the brighter the light, the higher the temperature, until the comet's surface begins to boil. Ancient layers of ice, preserved for millions of years, melt and erupt into streams of gas. Like the long breath of someone waking from an eternal sleep. This is why comets shine so brilliantly when they near the sun, their long tails marking the drama of that encounter. But Atlas's perihelion holds a peculiar twist. On the very day it swept past its closest approach, Earth was on the opposite side of the sun, completely hidden from the view. It's as if you were eager to watch a grand performance on stage, only for a heavy curtain to fall at the very climax, shutting out every glimpse. All of humanity missed the moment. It was a strange coincidence, a gap that forced scientists into patience, as though the universe itself was keeping a secret just out of sight. From a vantage point outside the solar system, the scene would have been spectacular. The sun blazing like a cosmic lighthouse, Atlas racing in, swinging close, skimming past within a breath of astronomical distance. Yet from Earth, there was only darkness. Our planet turned away, leaving us blind to what unfolded. It was like watching a stranger step into a room, only to be forced to look aside at the instant they do something crucial. Scientifically, perihelion is where orbits can change most dramatically. It's the perfect place for an object to gain or lose speed under the sun's pull. That's why some theorists suggest that if an alien technology were somehow riding with Atlas, this would be the moment to act, to slow down and stay, or to slingshot away forever. And yet, tragically, we wouldn't be able to see it happen. The cosmos handed us tickets to the show, only to block our view of the climax. This makes Atlas's perihelion more than just a physical event. It becomes an emotional pause, filled with anticipation and unease, like waiting for a crucial letter that still hasn't arrived. In those last days of October, when we looked up at the sky, there was perhaps a strange awareness lingering. Knowing that just beyond the sun's blazing curtain, a colossal traveler was living through its defining moment, invisible to us all. And then, after October 29th, Atlas slipped away, lost in the sun's glare, unreachable even to the best telescopes. We would have to wait until late November or December when it emerged again on the other side to see what had changed. Like a friend vanishing behind a door, only when they return can we know which path they chose. In that obscurity, speculation takes over. Predictions swirl, theories multiply, but the answers remain hidden, scattered in the rays of light. And because of that silence, Atlas's perihelion stands out all the more, a cosmic exclamation point suspended in the vastness. Thinking of it this way, we can sense that this is only the beginning of the story. Perihelion is not an ending, but the opening chapter to stranger calculations ahead. What unsettles scientists most is not simply the moment it disappeared behind the sun, but the sheer immensity of Atlas itself, so large that it seems to strain the probabilities of nature. And that is where the story leads next, as we ask why the size of Atlas makes even the universe raise an eyebrow. In the universe, there are moments like a single note ringing out in an endless symphony, fleeting yet powerful enough to shift the melody that follows. For Atlas, perihelion isn't just a brief pass by the sun, it's a rare chance to alter its own destiny. Out there, everything becomes more intense. Sunlight burns brighter, gravity grows stronger, and every tiny molecule of gas escaping its frozen surface joins the vast cosmic dance unfolding around it. In astronautics, there's a fascinating principle called the Oberth effect. It says that if an object wants to change its velocity, the most efficient place to do so is where it's moving fastest along its orbit, close to the sun or a planet. A small push at perihelion can make a huge difference, like a runner taking one last breath in the final sprint to break a record. We usually think of the Oberth effect as a way for spacecraft to accelerate, but in Atlas's case, it might play out in reverse, a reverse Oberth maneuver. Instead of speeding up to escape farther into space, it could slow down just enough to be captured by the sun, becoming a new resident of the solar system. Close your eyes and imagine standing somewhere along that orbit. Atlas rushes past like a guest bursting into a radiant square, racing toward the sun with everything it has. And with just the smallest shift, the faintest breath, it could stop, remain, and stay forever, rather than continue its journey into the unknown. The image feels like watching a choice unfold, a moment out of a fairy tale where the hero stands at a crossroads and a single decision reshapes the story forever. The astronomical weight of this moment is enormous. If Atlas really does slow down and become bound to the sun, it would mark the first time in human history that we've witnessed an interstellar visitor turn into a long-term neighbor. No longer a fleeting shadow, but a permanent witness in our cosmic backyard. If it carries something unusual within it, we'd finally have countless chances to study it. But if it keeps racing outward, it will remain just another name in the record books, like Oumuamua and Borisov before it, leaving us with more questions than answers. There's something poetic about the timing. As Atlas approaches perihelion, the sun itself blinds us, hiding the most dramatic part of the story. The universe feels like it's playing hide and seek, keeping the climax tucked behind a blazing curtain. Only weeks later, when Atlas emerges again, will we know whether it has changed or stayed the same. That wait feels like watching for a friend returning from a long journey, unsure of what stories or burdens they'll bring back with them. In every number, every calculation, Atlas's perihelion becomes a point of convergence. It's where physics and imagination meet, where science and hope intertwine. Astronomers look at it as though peering through the only window that might reveal the answer. For the rest of us, sitting beneath the starry sky, it's enough to listen, to imagine, and to let ourselves drift with the current of the story. Perhaps that's why perihelion feels important not just in mathematics or physics, but emotionally as well. It reminds us that sometimes a single moment, in the right place, at the right time, can change everything. Maybe the fate of Atlas and our own understanding of the universe will be shaped by this very instant. And thinking about that, it's hard not to wonder, is this timing truly just coincidence? Or is there a hidden secret in the way Atlas chooses its approach? That question leads us into another perspective, where strangeness lies not only in its shape or brightness, but in the improbable chain of coincidences that seem almost scripted. And that is where the story continues, as we begin to see Atlas through the lens of chances so slim, they feel like fate. In the grand machinery of the universe, most things follow strict, almost unforgiving rules. Planets circle the sun in steady orbits. Comets and asteroids trace paths that we can predict with precision. Every now and then there's a little surprise, like a shooting star streaking across the night, but in general, the cosmos doesn't seem to care much for coincidences. That's why, when astronomers realized that Atlas would reach its perihelion at the exact moment Earth slipped out of view, it felt more than a little strange. If this were nothing more than random chance, the odds of such a perfect overlap would be vanishingly small. It's like wandering through a massive city, and right at the moment you're about to glimpse something extraordinary, a stranger steps in front of you and blocks your view. That tiny probability is enough to make us pause, because perihelion isn't just a dot on a map of an orbit, it's a turning point. A place where the future of a body is decided, whether it continues on its path or changes course. And at that very moment, Earth couldn't watch. Picture yourself sitting in a theater. The curtain rises, the main character steps into the light, and just as the story builds to its most critical moment, someone walks past and blocks your line of sight. You can still hear the music, you can feel the tension in the air, but your eyes meet only emptiness. For Atlas, October 29th was that scene, and humanity, all of us, were the audience left in the dark. In science, we usually avoid reading too much meaning into coincidences. After all, in a universe this vast, even the rarest possibilities become inevitable if you wait long enough. But this one appeared while we were already watching one of the strangest objects ever to pass through the solar system, and that alone tempts the imagination. If you believe there could be some hidden hand at work, then perihelion in shadow becomes a perfect cover for a maneuver unseen. A slowing of speed, a shift in trajectory, all concealed in the brilliance of the sun. The thought of it is enough to send a chill down your spine. A massive, radiant body diving toward our star, and just when it might be doing something unexpected, we're forced to look away. It's like a secret whispered in a locked room, with only the sun as witness, while we stand powerless. Maybe it's all just coincidence, nothing more than mathematics playing its little tricks. But maybe it's something else, a perfect window of invisibility, that someone or something has taken advantage of. Even when we strip the mystery away and try to think rationally, the coincidence still stirs a faint unease. Because we know some things will remain hidden, and the answers will only emerge when Atlas emerges too, weeks later, from behind the sun. Until then, we can only sit beneath the quiet night sky, letting our imagination drift across the void, following that distant visitor. And like every story, this moment of mystery is just one piece of a larger puzzle. Small probabilities, strange orbits, each thread weaving into something greater. To understand it, we'll have to look closer at Atlas itself, so vast that it pushes the limits of our familiar calculations. When it comes to enormous numbers, our minds often struggle to truly grasp what they mean. A kilometer, 10 kilometers, 20 kilometers. Those sound simple enough. But when you place them in the context of the cosmos, they stretch into vast dimensions that go far beyond our everyday sense of scale. Atlas, from the very first estimates, was thought to span nearly 20 kilometers across. Spoken plainly, that number might feel abstract, almost unremarkable, but let's anchor it to something familiar: the island of Manhattan. Manhattan, with its towers piercing the sky and its lights glittering along the Hudson River at night, measures only about 13 kilometers in length, which means if Atlas were laid across a map, it could easily cover the entire bustling island, spilling past its edges by several kilometers. Those skyscrapers that scrape the clouds, that seem like steel spires reaching into the heavens, would shrink to mere specks of dust under Atlas's shadow. Imagine standing on Fifth Avenue, tilting your head back, and instead of the familiar stretch of blue sky, you're faced with a colossal black wall blotting out the sun. In that moment, you wouldn't just feel small, you'd feel like an ant wandering at the feet of a giant. But stopping at Manhattan still doesn't convey the full weight of that 20-kilometer figure. To understand it, we need to recall not our own memory, but the Earth's. 66 million years ago, a massive asteroid roughly 10 kilometers wide slammed into what is now Mexico's Yucatan Peninsula. That single impact carved out the Chicxulub crater, choked the skies with dust, collapsed ecosystems, and ultimately wiped out most of the dinosaurs. A space rock only half the size of Atlas was enough to rewrite the entire history of life. So when you hear that Atlas was once believed to be twice as large, the story takes on a far more chilling edge. If, hypothetically, Atlas had been on a collision course with Earth, the outcome wouldn't just have been catastrophic. It would have been the end. Its power could erase not only civilizations, but whole chapters of life itself. Thankfully, its orbit is harmless. But even entertaining that thought, for just a moment, reminds us of how fragile our perch really is, living on a small, delicate world adrift in an unforgiving universe. There's a striking contrast at play here. On Earth, we often look at skyscrapers, cities, or monumental structures as symbols of power and grandeur. But under the gaze of the cosmos, those ideas dissolve in an instant. A crowded Manhattan with millions of people is nothing more than a speck beneath the shadow of a wandering interstellar body. And it's precisely in that contrast that we feel fear, awe, and wonder all at once. We feel tiny, yes, but also profoundly fortunate to be alive in the fleeting moment when the universe lets one of its giants drift close enough for us to notice. Later, of course, Atlas was re-estimated, smaller than those early numbers suggested. Yet that fleeting belief that it could have been as vast as 20 kilometers still lingers like an echo that beats like a drum in the mind, reminding us that the universe is full of possibilities that stretch far beyond imagination. And in that resonance, we become more aware of our own fragility, and just as aware of the improbable luck that allows us to witness a story this grand. And that's only the beginning, because once we've wrestled with the size of Atlas, a new question emerges. If such massive objects really do drift out there, how likely is it that we would stumble upon one? And if the statistics say it's improbable, then what does the appearance of Atlas tell us about deeper mysteries? To answer that, we'll have to keep going and turn to the natural laws that govern how these objects are distributed, where probability and numbers lead us toward the next set of cosmic anomalies. In astronomy, there's a quiet but persistent rule, like the steady breathing of the universe. It's called a power law distribution, a principle that says small objects are everywhere, while large ones are so rare you'll almost never run into them. Imagine standing on a beach, sand stretching beneath your feet. You'd see countless tiny grains, but to find a single boulder, you'd have to walk a long way. The cosmos works the same way, overflowing with countless little fragments, while only on the rarest of occasions does a true giant appear. By that logic, if we opened a door into interstellar space, the first thing we'd expect to meet would be thousands, maybe tens of thousands of tiny bodies just a few hundred meters across. Only after a long wait might we stumble upon something massive, several kilometers wide. It's like rainfall on Earth. Light showers are common, but a true storm is something you wait a long time for. And yet, with Atlas, the story seems flipped upside down. In just a few short years of paying attention to interstellar visitors, we've already seen not just Oumuamua and Borisov, but also a towering giant like Atlas. It's as if you bought a lottery ticket for the very first time and immediately won the jackpot. Then, buying a few more, you won again and again. One stroke of luck might be dismissed as chance, but if it keeps repeating, you can't help but wonder if something unusual is happening. Looking up at the sky, the feeling is almost unreal. The universe is vast, like an endless desert where tiny grains of dust drift for billions of years without us ever noticing them. Yet, the moment we begin to look, a mountain of ice passes right before our eyes, as if it had been waiting for us all along. It sparks the imagination, as though an invisible hand had arranged things so that we wouldn't start with scraps, but instead be confronted with the extraordinary. In science, we have to be careful. Rare things do happen, and what looks miraculous may just be a fleeting coincidence in the bigger picture. But what's hard to ignore here is the speed. In barely a decade, humanity has encountered 3 interstellar visitors, and among them, Atlas is far larger than the rest. If the natural distribution holds true, this kind of luck is like pulling the rarest card from the cosmic deck, and not just once. There's a strange silence in that thought. We, fragile creatures on a small blue planet, have looked up and seen a visitor that, by probability alone, shouldn't appear for thousands of years. It's like sitting by a lake at night and catching a meteor streak across the sky, only instead of vanishing in a blink, it blossoms into a brilliant flare that lingers. You know it isn't normal, but you can't look away. And it's precisely this abnormality that pushes the story in a new direction. Because if the numbers don't add up, we have to ask, is there something wrong in how we understand interstellar matter? Or is there something unusual in the very nature of Atlas itself? To find out, we need to look closer at its immense mass and at whether there's a deeper explanation for why something so big, so soon, has crossed our path. When a comet drifts close to the sun, it usually comes alive. Its surface, frozen for millions of years, begins to melt, releasing ancient ice buried deep within. Gas and dust escape into space, streaming behind it to form the brilliant tail we see glowing across the sky. This process is called outgassing, and it doesn't just create beauty, it can also nudge the comet off course. Each jet of gas acts like a tiny thruster, pushing the body ever so slightly, leaving subtle signs that scientists can measure. But Atlas didn't quite follow that script. As it entered the warmer regions of the solar system, observers watched it outgas fiercely, shining brightly with a clear tail trailing behind. Yet its orbit barely changed. It glided forward with an almost unsettling calm, like a giant ship holding its course through a storm. This raised an unsettling question. How could something venting so much gas remain completely steady on its path? The most reasonable answer is simple. It's just too heavy. For outgassing to alter a comet's orbit, the comet must be light enough to be pushed. But if it weighs 33 billion tons, as minimum estimates suggest for Atlas, then those streams of gas are nothing more than the flap of a butterfly's wings in a hurricane. They sparkle, they shimmer, but they're powerless against such immense mass. To picture this, imagine a dry leaf floating on a pond. A single breeze can shift it, making it tremble and drift. Now replace the leaf with a mountain of stone. The wind can blow, the water can flow, but the rock won't move. Atlas is that mountain, wandering through space, unmoved by the faint breaths rising from its own surface. There's a kind of awe in the number 33 billion tons. It's so vast that human comparisons fail. Our largest ships, our busiest cities, even the grandest monuments we've built, all shrink into toys beside it. Its sheer bulk makes it extraordinary. In the cosmos, balance is fragile. Small comets wobble and shift, but Atlas drifts like a calm giant, betraying no sign of being disturbed. This difference is more than just science. It's a feeling. Sitting beneath the night sky, knowing that a body weighing billions of tons is passing silently overhead, steady as if it were programmed, you can't help but feel tiny. It's like standing before a towering cliff that has stood unmoved for millions of years. Atlas carries that same immovable stillness, leaving us to wonder, is this truly a natural comet or something designed to hold its course so perfectly? And here, imagination begins to stir. If it's only ice and rock, why is it so heavy? If it's hollow, like a shell floating in space, what secrets might its outer layers conceal? These thoughts don't answer the mystery, but they open it up, like a melody echoing in the night, lingering long after you've drifted to sleep. Atlas's enormous mass and uncanny steadiness against outgassing form an essential piece of the puzzle. They tell us this is no ordinary object. To dig deeper, we need to consider a bolder possibility, that inside this colossal traveler, there may be nothing at all, just a hollow shell adrift in the dark. And that is where the story opens further, with even greater surprises waiting ahead. On quiet nights when we sit and gaze at the sky, it's easy to imagine celestial bodies as nothing more than giant, solid rocks drifting silently through space. Comets, asteroids, cosmic debris, we often picture them that way, as frozen chunks of ice and stone, heavy and lifeless. But with Atlas, when the numbers for its mass and motion didn't line up, a bold idea emerged. Maybe it isn't solid at all, but hollow. That thought sounds like something out of science fiction, yet it rests on very real science. If Atlas were just an ordinary comet, the powerful jets of gas streaming off its surface should give it tiny pushes enough to nudge its orbit. But that never happened. One possible explanation is that it's so massive, the outgassing barely matters. Yet its mass doesn't match the estimates of its brightness and the way it reflects sunlight. A subtle but crucial contradiction. Enough to make scientists wonder. Something here doesn't add up. The hollow structure hypothesis entered like an odd note in the symphony. Imagine, instead of a dense rock, Atlas is more like a shell, a cosmic egg drifting in space, with emptiness inside. That mix of large size but low mass could explain its strange behavior. And in that fleeting moment of imagination, it's hard not to picture a colossal spacecraft, cloaked in ice and dust, disguised as a natural wanderer of the stars. Close your eyes, and you can almost see yourself standing before Atlas. From afar, it looks like a floating mountain. But as you draw near, its jagged cliffs come into view, deep cracks cut through its surface, faint wisps of ice turn into vapor. And then the sound, or rather the echo, is not that of solid stone, but the hollow resonance of a cavern, vast and eerie. That empty space sends a chill down your spine, as if you could step inside and lose yourself in another world. Of course, this is only a hypothesis, and science demands evidence. No one can claim Atlas is a ship or that it was shaped by any hand other than nature's. Yet this is the beauty of science, the way it allows us to ask daring questions, then test them against data and observation. And the hollow structure idea, wild as it may sound, helps untangle the contradictions the numbers keep whispering. It's fascinating to think that if Atlas really were hollow, it wouldn't resemble the classical image of a comet at all. It would look more like something designed with intention, an inner chamber like a waiting heart. That thought alone, even as pure imagination, slows the beat of our own hearts, reminding us that the universe is always larger than the boxes we try to fit it into. Its mass has already given us riddles, and a hollow core is only one of many possible answers. But if the mass leaves us puzzled, Atlas's orbit raises even stranger questions. Because its path isn't just a simple curve, it feels like a delicate stroke of design, drawn to pass through certain places as if on purpose. And to understand it more deeply, we have to keep going, to look closer at how Atlas's journey through space has managed to surprise even the most cautious minds. When we look up at the night sky, the universe feels chaotic and endless. Stars scatter in every direction with no clear pattern, like sparkling grains of dust on a velvet canvas. But hidden inside that seeming chaos lies an invisible plane, quietly shaping everything in the solar system. Astronomers call it the ecliptic, the shared path that planets, asteroids, and most comets follow, like dancers circling a flat, glowing stage with the sun blazing at its center. What makes this so curious is that interstellar objects, those rare visitors from beyond our solar system, have no reason to obey this rule. They come from distant star systems, drifting for millions or even billions of years through the void. By all logic, their paths should be random, cutting across our solar system from any angle. For one of them to fall perfectly into the ecliptic is like flipping a coin hundreds of times and having it land on its edge every single time, a probability so small it borders on impossible. Scientists estimate the odds of an object like Atlas lining up with this plane by sheer chance at just 1 in 500. Pause for a moment and imagine what that really means. 1 in 500 is like lining up 500 doors, and only one leads to the right room. If a traveler from the stars happened to step through that exact door on their very first try, you'd be forgiven for suspecting there was more at play than luck. Atlas is precisely that traveler, moving along a path so flat and precise it feels as if it has long known this stage. If we could stand out there, right on the ecliptic, and watch Atlas approach, it would look less like a rock tumbling in from the void and more like a lone wanderer walking steadily down an infinite road. It doesn't plunge in from above or slice across from below. Instead, it joins the great procession, gliding alongside Jupiter, Venus, and Mars, as if it belongs. That quiet harmony is striking, almost as though this visitor didn't just stumble here, but chose a route that would let it blend in, be observed, and perhaps even remain unnoticed. Throughout the history of astronomy, whenever something aligns too perfectly, it makes us stop and ask questions. Is it really just coincidence, or the sign of something more deliberate? With its orbit hugging the ecliptic, Atlas plants that doubt in our minds. Maybe it's nothing more than the unlikeliest of accidents among millions of others. But maybe, just maybe, it's a choice, a careful step taken by a traveler unwilling to stray too far from the music the planets are playing. That image is hard to resist. If the sun and planets form a grand symphony, then Atlas isn't a jarring drumbeat out of place. It's a note set perfectly into the score, blending with the melody. Close your eyes and you can almost hear it. The orchestra swelling and this quiet guest slipping in, not disrupting the rhythm, but adding depth, layers, and mystery. And so we find ourselves asking, why? Why would a visitor from so far away choose this exact plane? Is it really just a frozen chunk of ice wandering through space? Or could there be something more, some force or intelligence guiding its path? We don't have an answer yet, but the question itself reminds us that the universe doesn't only hold what's obvious. It hides strange harmonies too, the kind that slow our heartbeat every time we pause to wonder. And perhaps this alignment is only the opening note of a longer composition. Because if the orbit itself is already this precise, then the way Atlas goes on to approach 3 of our giant planets at just the right moments makes the story even stranger. That's where our journey continues, listening to how Atlas moves like a dancer, stepping closer to its 3 enormous partners on the solar system's stage. In the silent dance of the cosmos, giant planets circle the sun with their own steady rhythm, each one moving like a dancer on an endless stage. Earth, Mars, Venus, Jupiter, they've been keeping time for billions of years. And then, from the distant dark, a stranger drifts in, carrying its own path, as if unaware of the choreography already in motion. Strangely enough, it arrives not only at the right time and place, but passes close by 3 great planets, almost as though it had chosen its partners in advance. The first encounter is with Mars, the lonely red world sitting just beyond Earth's orbit. Atlas approached closer than any interstellar visitor we've ever recorded, skimming by at only 29 million kilometers. On a cosmic scale, that's barely a blink, a handshake close enough to feel the warmth of breath. If you were standing on Mars at that moment and looked up, you might have seen a brilliant green star streaking across the sky, leaving a glowing trail like a greeting from the unknown. It didn't land, it didn't linger, but its nearness carved a memory into the dusty skies of the red planet. From there, Atlas didn't fade quietly away, but continued on its path, gliding past Venus, the brightest jewel in our night sky. Venus, wrapped in thick clouds that veil its burning surface beneath golden haze, met this traveler with a fleeting vision. Atlas appeared as a strange new light, a wanderer who paused only to nod in passing before moving on. There's a kind of poetry in that, a chance meeting between strangers at a roadside stop, exchanging a single glance before vanishing back into the endless journey. And then came the most important encounter: Jupiter, the giant king of the solar system. With a gravity strong enough to hold dozens of moons in its embrace and to shield smaller worlds from cosmic debris, Jupiter commands its own vast court. Yet Atlas chose a path close enough to make scientists sit upright in surprise. It didn't collide, and it wasn't pulled in. Instead, it brushed by at just the right distance, like a whispered conversation between two titans. If you were standing on one of Jupiter's icy moons, you would have seen Atlas pass by as a mysterious streak of light fading away toward the sun. 3 encounters, 3 moments of crossing paths with 3 great planets, all in a single journey. The odds of this happening by chance? About 1 in 20,000. Imagine rolling dice 20,000 times and only once do they fall exactly the way you need. Atlas was that rare throw. Such a coincidence stirs something inside us, whispering that maybe this wasn't pure randomness after all. Perhaps this traveler isn't merely drifting, but walking a path refined to the rhythm of hidden steps. In the quiet darkness of space, these close approaches were like brief, graceful dances. Mars, Venus, Jupiter, familiar figures of the solar stage, became Atlas's partners for a moment before it returned to its solitary waltz. And we, tiny spectators on Earth, can do nothing more than watch from afar, recording numbers and orbital models, while our hearts keep wondering, was this only an improvisation or a performance written long ago? Whatever the answer, one truth remains: the unlikely has happened, and we've witnessed a strange play unfold. Yet the story is not over, for the greatest mystery lies not in the chance encounters, but at the very heart of Atlas's orbit, its perihelion, the moment it comes closest to the sun, where it may yet decide its fate. And that is where we will continue to follow, listening for the secrets hidden within the dazzling light of our star. When we think about interstellar objects, our minds usually go to ice and cosmic dust, to frozen rocks wandering in from some distant star system. But there's a bolder idea, one that stretches the imagination. What if Atlas isn't just a comet, but a vessel carrying some kind of mission? What would that mean? Scientists have asked before, if an extraterrestrial civilization wanted to explore our solar system, would they really need to send a giant starship? Or could they simply disguise their instruments beneath a shell of ice and dust, hiding small devices inside, just enough to observe, record, and send information back? In that light, Atlas, wrapped in its dense cloud of dust, could be the perfect cover. Picture this. As Atlas sweeps past a planet, it could quietly release a tiny probe. Hidden within the comet's shimmering trail, it would be so small our telescopes would never notice it. It would drift silently through space until slipping into orbit around a planet, or perhaps landing on the surface of some lonely moon. From there, it could watch, listen, and wait. Close your eyes and imagine the scene. A greenish tail glows against the dark, while particles of dust scatter like snow in the wind. Somewhere inside, a small object, no larger than a rock, breaks away, spinning among countless other fragments. No one pays attention because it looks like nothing more than debris. Yet inside, there could be circuits, antennas, even technologies far beyond anything we can imagine. A grain of dust that can listen. Of course, this is only speculation. There's no evidence that Atlas is doing any of this. But what makes the idea compelling is how plausible it sounds. If a civilization wanted to observe without being noticed, using a comet as natural camouflage would be nearly perfect. Instead of drawing attention with a gleaming starship, they could send something everyone would mistake for just ice and dust. The real instruments could be tucked inside tiny particles, scattered quietly as the comet drifts past key worlds. And it's here that the thought becomes both eerie and strangely poetic. Because maybe, right now, somewhere in the solar system, on Mars with its red, dusty plains, within Venus's golden clouds, or on a frozen moon of Jupiter, a single grain of dust lies still, listening, doing nothing, only waiting, like a seed buried in the soil, silently biding its time. Most likely, of course, this is just our imagination running wild. Atlas could very well be nothing more than a grand, dazzling comet. But the human mind is wired to wonder, to reach for possibilities beyond the obvious. And sometimes the boldest ideas remind us just how vast the universe really is, and how truth, whatever it may be, often outpaces our imagination. Whether it's a natural chunk of ice or something else entirely, Atlas still shines across the sky, leaving us with questions we can't yet answer. And maybe the most natural question of all is this. When we look at Atlas, does it truly appear like any other comet, or is there something about it that should give us pause? Astronomers noticed something strange when they pointed the Hubble Space Telescope toward Atlas. Instead of the familiar soft, trailing tail stretching across the sky, the signature image we associate with comets, they saw a concentrated beam of light pointing back toward the sun. It looked like a pair of headlights switched on in the darkness, shining directly into the heart of the solar system. Normally, a comet's light streams away from the sun, its dust and gas swept back by the solar wind to form that long romantic tail, the very image that has stirred myths and wonder since humans first gazed at the stars. But Atlas didn't behave like that. Its tail wasn't there in the usual way. Instead, a sharp burst of light seemed to flash forward, right where we'd expect the darkness to be. The standard explanation was simple: a photographic effect. Light and dust slipping into the telescope might have created an illusion, a trick of optics, rather than reality. A small glitch in Hubble's vision, perhaps just a joke played by light as it passed through delicate machinery. Yet Avi Loeb, always attentive to the odd and the unexplained, wasn't so quick to dismiss it. Sometimes, he argued, what we call an illusion is actually a hint, reminding us that something important still lies beyond our understanding. If you close your eyes and imagine it, Atlas becomes a cosmic caravan moving through the night. Unlike its comet cousins, trailing long veils of stardust behind them, Atlas seemed to turn on its headlights, cutting a path forward toward the sun. That light felt intentional, as if the object were searching its way ahead or sending a signal to someone waiting in the distance. Of course, this could all just be imagination, our minds exaggerating when faced with something unexplained. Still, the fact remains, Atlas was not behaving like an ordinary comet. And that strangeness alone is enough to spark 1,000 questions. If this was only an optical effect, why did it appear in the one moment that left us so unsettled? And if it wasn't, then what was that light? A peculiar reflection, or something beyond the natural patterns we know? Picture yourself in the silence of night, sitting on the shore of the cosmic ocean, watching an unfamiliar traveler approach. A sudden green glow bursts from ahead, not like the gentle shimmer of stars, nor the fiery streak of a comet's tail, but more like a glance returned, a whisper saying, "I'm coming." It may be nothing more than coincidence, yet in that coincidence, the human heart finds meaning, something that feels uncannily close to the language of life itself. In that instant, Atlas was like an actor stepping onto the stage, only to reveal a costume no one expected. The audience stirred, unsettled, curious. And as in every story, that twist opens a new chapter. If its light was unlike a comet's, then what will its strange chemistry and unusual colors tell us next? There's a familiar image we always carry with comets. That long, soft tail of light streaming behind them, like a cosmic veil the sun has woven out of ice and dust. For millions of years, frozen blocks have drifted silently through the cold, empty dark until one day they wander close enough to the warmth of our star. Then they awaken, thawing, venting, painting a shining streak across the sky, something humanity, for centuries, has read as a sign, a message from above. With Atlas, people expected the same, a luminous ribbon trailing behind, proof that it had truly become a comet. But something strange happened. As Atlas began its descent into the solar system, it didn't reveal that familiar banner. No billowing clouds of dust under the sun's glare, only a glowing body moving forward without the radiant veil we've come to expect. Only much later, as it drew closer and the distance grew small, did the tail begin to emerge. Slow, hesitant, almost overdue, like an actor wandering onto the stage long after the curtain should have risen. In scientific models, a comet's tail usually begins much farther out, hundreds of millions of kilometers away, as buried ice starts to sublimate. But Atlas didn't follow that script. It kept its compact, unassuming form for an unusually long time, only to flare open suddenly, much later than anticipated. Scientists tried to explain this oddity, suggesting it might have a different composition, perhaps richer in carbon dioxide, poorer in water, making its outgassing behave differently. Yet, no matter the explanation, that lateness left behind a lingering sense of mystery. If you could stand somewhere in the dark void and watch, it would feel like watching a traveler moving through a crowded market, cloak pulled tight, face hidden, revealing nothing. Until reaching the central square, where at last the cloak is thrown open, spilling out light and drawing every gaze. A comet's tail is usually an early greeting from afar, but Atlas stayed quiet until the very end, arriving late yet dazzling. That delay stirred another thought in some minds. What if Atlas were not just rock and ice, but a design, a colossal machine? In that case, withholding the tail could be a strategy. Beautiful though it may be, the tail is also a beacon, announcing to the cosmos, this is a comet. If one wanted to remain hidden longer, silence would be the perfect disguise, the cloak pulled shut until the right moment. Only once deep inside its path would the radiant garment unfold, like a performance precisely staged. Of course, that's only human imagination. But the truth remains, Atlas behaved differently, revealing itself later than most comets. And sometimes, it's in these small irregularities that the seeds of great theories are sown. Sitting beneath the night sky, we can take this as a lesson in patience. Some things do not rush to display their beauty. They wait, holding back until the right moment, and when they finally bloom, the effect is even more profound. Like a late flower in the garden, the longer the wait, the more precious it feels. Atlas carried that same slowness, holding off its unveiling, so that when the tail finally appeared, it struck with surprise and weight. And this was only one piece of the puzzle, because when the tail finally showed itself, it bore something even more unusual, a greenish glow, rare and hard to explain. A color that turned an already mysterious sight into something hauntingly magical. There was a special moment in Atlas's journey, when it drew closer to our central star. From a faint, pale white speck, it suddenly flared to life, glowing with an eerie green light, as if someone had flipped a cosmic switch. This glow wasn't the golden blaze of stars or the silvery shimmer of the moon, but something colder, stranger, radiating from the comet's frozen body. Scientists have a theory. They believe the glow comes from molecules like C2, diatomic carbon, or cyanide, compounds that break apart under sunlight and release a green fluorescence. But what captured attention wasn't just the presence of these molecules, it was the way the light appeared. Not gradually, faintly, or hesitantly, but suddenly, decisively, as if a hidden system had been activated the moment conditions were right. Imagine standing somewhere in the vastness of space, watching. A frozen wanderer, silent and dark for billions of years, suddenly awakens as it crosses into sunlight. Like a colossal machine stirring to life, its control panel blinking green, signaling that from this instant onward, it has shifted into a new state. Everything feels so precise, so perfectly timed, that it's hard not to wonder whether this was more than just an accident of nature. That green light sparks familiar yet distant associations. It resembles stars half-veiled in fog, or the bioluminescent shimmer of deep-sea creatures that glow to communicate in darkness. Out there, in the near-absolute blackness of space, Atlas's glow looks like a beacon, a lighthouse flickering on as an icy ship enters uncharted seas. Perhaps the truth is simple, that Atlas's icy shell is just reacting through ordinary chemistry. Yet human minds rarely rest with simple answers. We see that glow and can't help but imagine something alive within it, as though the comet were breathing, opening its eyes, running a silent system check before continuing its long voyage. It's an image that invites reflection. Because sometimes, even in our own lives, there are moments when something inside us flicks on like a switch. A sudden idea sparks, a feeling floods the heart, a decision reshapes the entire path ahead. Atlas, in its emerald moment, reminds us that everything has its time, and when that time comes, transformation can be instant, without hesitation or delay. And yet that green glow was only one piece of a far stranger puzzle. Looking deeper, astronomers found not only its unusual color, but also chemical ratios that didn't quite add up. Most strikingly, an imbalance between carbon dioxide and water, a ratio so perplexing it left researchers even more unsettled. And that is where the story carries us next. into numbers that may look dry at first glance, but conceal another layer of mystery about the true nature of Atlas. In the study of comets, their chemistry often holds the key to uncovering their origins. Each comet is like an ancient archive, carrying the chemical recipes from the dawn of the solar system. Most of them share a familiar balance of water and carbon dioxide, a melody that has been repeating for billions of years. So when astronomers turned their gaze to Atlas, they expected to hear that same tune again, hoping it would reveal where this traveler belonged. But what they found was not the usual harmony, but something offbeat, a strange note ringing out against the orchestra of the cosmos. Instead of a gentle balance between water and carbon dioxide, Atlas revealed an astonishing number, a ratio of 8-to-1 in favor of carbon dioxide. In scientific terms, that difference is massive, almost breaking the rules. In human terms, it's like taking a sip of wine you expect to be sweet and smooth, only to find it burning and unfamiliar. Close your eyes and picture Atlas passing through the sunlight. Instead of the faint, misty breath of water vapor, plumes of dense carbon dioxide erupt from its surface, spilling out cold and dry. It's as if this object wasn't born in the usual neighborhood where comets dwell, but in a far harsher place, where water ice is scarce and carbon reigns. Scientists tried to explain it, suggesting Atlas might have formed in a peculiar region of a distant star's disk where temperature and chemistry tilted the balance. Yet the fact remains, few comets in our solar system show such bizarre proportions. And that raises an unsettling question. If not a quirk of nature, could it be the result of something artificial? In imagination, one might picture a colossal machine cloaked in dust and ice, burning carbon dioxide as fuel, leaving behind strange chemical traces of its hidden workings. When touched by sunlight, the system stirs to life, venting streams of gas in ratios unlike any natural body. Of course, this is pure speculation, tinged with science fiction, but it lends Atlas's green glow and its chemical oddities an extra layer of mystery. From afar, Atlas drifts through the cosmic dark as something half familiar, half strange. Part of it belongs to nature, yet another part defies every model we know. And that duality stirs both wonder and unease, reminding us that not every story follows the same well-worn path. Sometimes, amid the chaos, a strange signal rises above the noise, and all we can do is listen closely. With every piece of evidence, the questions grow larger. Its eerie green light, its belated tail, its massive bulk that refuses to shift orbit, and now its wildly unusual chemistry. Threaded together, these details seem to point toward a far greater question. Is Atlas simply a peculiar comet? Or could it be something else entirely? A technology from beyond Earth? In science, sometimes we need a simple language to talk about complex things. When it comes to strange phenomena like Atlas, Avi Loeb proposed a scale from 0 to 10 to gauge how likely it is that an object is a product of alien technology. A 0 represents complete normalcy, a lifeless rock drifting quietly through space, nothing to raise an eyebrow. A 10, at the other extreme, is a definite confirmation the moment you touch a spacecraft and realize you are not alone. Every number in between captures degrees of curiosity, of hope tinged with doubt. For Atlas, Loeb suggests it sits somewhere around 5 or 6. Not low enough to ignore, but not high enough to claim certainty. It's a gray area where the human mind is both captivated and cautious. A typical object would fall at 0 or 1, just ice and dust. A minor anomaly might push it to 2 or 3. But Atlas, with its massive mass yet unchanging trajectory, its oddly tuned orbit, its flashes of green light like a switch turning on, and its unusual chemical makeup, takes it further. A 5 to 6 marks the middle ground, where doubt transforms into a question worth following seriously. If you imagine this scale as a road, 0 to 10 is the journey from the ordinary to the extraordinary. Atlas stands somewhere in the middle, like a traveler at a crossroads. It could turn down a familiar path, proving itself just an unusual comet. Or it could move further, each step hinting at an invisible hand guiding it. And we, the watchers, can only follow with bated breath, uncertain which way it will go. What makes the Loeb scale so compelling isn't just the numbers, it's how it reflects the nature of human curiosity. We know the odds that an interstellar object is alien technology are vanishingly small, yet we also know that if we don't ask the question, if we don't dare to place it somewhere on the scale, we might miss the chance to recognize something extraordinary. A 5 to 6 isn't evidence, it's a whisper saying, pay a little more attention. Imagine if we could see Atlas with eyes unbound by telescopes. We'd witness a massive glowing object streaking across the night sky, carrying its silent secrets. In that light, we couldn't say for certain whether it's a machine or an iceberg. But something feels off, like a familiar song with a wrong note, compelling us to listen again. That's why it doesn't sit at 0, but in the middle of the journey, where the unease lingers unresolved. There's a certain beauty in giving ambiguity a number. It's like measuring wind strength, brightness, or even the heat of a spice. The scale doesn't tell the whole truth, but it gives us a shared language to discuss, debate, and convey that something unusual is happening. And with Atlas, 5 to 6 is an invitation to keep observing, to keep dreaming, and to keep asking questions. Yet, like any measure, it's only part of a bigger picture. A number matters only in context. When we remember Atlas isn't alone, it's one of 3 interstellar visitors humanity has ever encountered, and compared to its predecessors, it carries a much longer string of anomalies. From here, the story expands into a larger vision. Do we need an international system to monitor these cosmic visitors so that no sign from the far reaches of space goes unnoticed? Throughout history, humans have looked up at the sky and felt fear at the sight of sudden streaks of light, comets with blazing tails, or meteorites exploding in the atmosphere. We assigned them omens and prophecies simply because we had no tools to understand them. Today, with advanced technology, we know far more about orbits, chemical compositions, and collision risks. Yet there remains a strange gap. There is still no global organization, no collective eye of humanity dedicated to tracking interstellar visitors like Atlas. It's worth pausing to consider this. We have networks monitoring near-Earth asteroids, projects searching for potentially dangerous objects. But when it comes to bodies arriving from the vastness between the stars, messengers from a distant galaxy, we still rely on scattered observations, isolated research teams, and individual telescopes, piecing together fragments of data. It's like sending out a massive expedition across the ocean with no shared map, only scattered hand-drawn charts. Imagine the universe as a dark ocean, and Earth as a small boat drifting silently across its expanse. Every time an interstellar object passes through, it's like another ship appearing on the horizon. In the darkness, you might spot a faint light, hear an unfamiliar sound, but without lighthouses or communication systems, it's all guesswork. And our little boat, if unprepared, could miss crucial signs, or worse, face danger without warning. Avi Loeb and many other scientists have emphasized that to truly understand visitors like Atlas, we need more than isolated efforts. We need a coordinated global observation network overseen by an international organization where every piece of data is shared in real time, where telescopes, satellites, and even space missions work together seamlessly. Only then can we ensure we don't miss the fleeting moments when objects like Atlas pass by, carrying secrets that could change the way we see the universe. Picture such a system. Every time a strange celestial body appears, hundreds of electronic eyes turn toward it simultaneously, tracking every flicker, every glimmer, every subtle movement. Data is shared instantly across nations, crossing borders and private interests, because these visitors belong to no one but to the shared story of all humanity. We would no longer wait anxiously, piecing together fragments, but instead see the full, clear, and vivid picture. Perhaps this idea carries an even deeper hope. A network like this, if it were built, would not only help us track comets and interstellar objects, but also stand as proof that humanity can cooperate in the face of the vast cosmos. In a world where differences and conflicts often divide us, looking up at the sky together could become a unifying thread. Out there, in the endless ocean of space, we are all in the same boat. When we think of Atlas, of its peculiarities, from orbit to light, from mass to chemical makeup, the need becomes even clearer. A visitor like this cannot be ignored, cannot be observed in isolated fragments. It reminds us that the sky still holds countless secrets, and that it's time for humanity to have a shared eye to watch together. But this question of preparation leads to another, even more unsettling thought. If other civilizations truly exist out there, are they always friendly, or could they sometimes harbor hidden dangers? That's when we confront a thornier hypothesis, a vision some call the dark forest. And that's where the story takes us next, diving into profound reflections on our existence in the universe. In the pages of science fiction, there's a chilling idea that sends shivers down the spine because of its sheer coldness. It's called the dark forest hypothesis. The image it evokes is simple, yet it carries a terrifying truth. Imagine the universe as an endless forest, where every civilization is a silent hunter. Everyone knows others might exist out there, but no one can be sure whether the stranger is friendly. And in the darkness, a harsh rule applies. Whoever makes a sound, whoever reveals their location, risks becoming prey. This hypothesis was introduced by Liu Cixin in his three-body problem trilogy, and since then, it has become a notion that makes not only readers, but many scientists pause and reflect. Logically, it's not absurd. A civilization might be weaker than you, but you can't know for sure. It might be thousands of times stronger, and a single misstep, a careless signal, could inadvertently invite your own destruction. In such a forest, silence becomes a survival strategy. And now, when we look at Atlas with all its strangeness, it's hard not to feel that same chill. If it's just a chunk of ice, there's nothing more to say. But if it carries technology, then we have to ask, what is its purpose? Could it be a gift, a friendly greeting? Or is it a watchtower, a quiet eye observing us from a safe distance? Even worse, could it be an arrow shot from a hunter hidden in the shadows, testing whether we have any vulnerabilities? In our imagination, we can picture this as a foggy night in a dense forest. You hold a torch, illuminating only a few steps ahead. Suddenly, you hear leaves rustling somewhere in the distance, but you can't tell if it's the wind, a small animal, or a predator lying in wait. What do? Shout loudly to show you're not afraid, or remain utterly silent, even holding your breath? Perhaps our universe feels the same way. Avi Loeb often emphasizes that science shouldn't stop at the familiar. He argues that if there's an unusual signal, we must be willing to consider the extraterrestrial hypothesis, even if it's uncomfortable, even if some people smile skeptically. Ignoring that possibility is like walking blindfolded through a dark forest, leaving your fate to chance. And here, the dark forest hypothesis serves as a stern reminder. Not every technology we encounter is friendly. Out there, if other beings exist, they could be as fearful as we are, as cautious as we are, and sometimes that fear can turn into aggression. Yet, amid all this anxiety, there's a softer note. The very existence of a concept like the dark forest shows that humans, with all our fragility, still long to understand and survive. We imagine the darkest scenarios not to spread fear, but to prepare for the worst, while keeping hope for something better alive. Perhaps the forest isn't entirely dark. Perhaps there are small lights, outstretched hands, civilizations that don't want to hunt, but simply wish to listen and share. Whatever Atlas turns out to be, whether a distant icy rock or a hidden craft, the truth is it makes us look at ourselves. It gives us the chance to ask, if one day we encounter real extraterrestrial visitors, how will we respond? Will we tremble in silence, or will we courageously light our torch and step out of the shadows? From that thought, the story subtly shifts. If we truly want answers, we need more than hypotheses, more than fear. We need action, preparation, and a strategy to protect this small planet in case the forest out there really does harbor hidden hunters. And that is where the next chapter of our story takes us, into the realm of planetary defense, an idea that belongs not only to science, but to the very survival of humanity. In the darkness of the cosmos, every time we encounter a strange visitor, the first question whispers softly, what should we do next? For Atlas, this isn't just a matter of pure curiosity. It's a strategic puzzle, at once scientific and deeply philosophical. The simplest thing humanity can do, and what we've been doing all along, is to observe. Our eyes alone can't reach it, but telescopes can. Towering, cold lenses perched on mountaintops or floating in space patiently gather every faint photon it emits. Each streak of light captured on film, every tiny fluctuation in the spectrum, is a piece of an unfinished puzzle. It's as if we're glimpsing a shadowy figure through the fog, trying to discern whether it's friend or stranger, harmless or a harbinger of danger. But observation alone isn't enough. For decades, humanity has debated whether we should send signals out into the universe. The golden Voyager discs, radio transmissions, friendly greetings in multiple languages, all are ways we whisper to the void. If Atlas truly is an alien technology, sending a proactive signal could be the first gentle knock at its door. A simple greeting, non-intrusive, just to say, "We know you're there." Yet with this idea comes a tense silence. In a dark forest, could that call turn out to be a mistake? The deeper challenge is that their technology, if it exists, might be far beyond ours. A human radio sending a signal into space is like lighting a fire with twigs, while someone out there is already using precise lasers or particles carrying information we've never imagined. We can send signals, we can wait, but how can we know if we're capable of hearing a response? A whale may sing across the ocean, and the little fish around it will never grasp the meaning of its song. Likewise, if they speak, do we even have the tools to listen and understand? So perhaps the wisest strategy is a balance of both. Meticulous observation, searching for any hint of the unusual, paired with measured signals, loud enough to be noticed but not blaring, welcoming yet cautious. Like entering a strange room, knocking gently while peeking through the crack in the door to make sure no danger lurks inside. What makes the story even more compelling is the sense of waiting. We might wait weeks, months, even years to see if Atlas responds with a sign. It could be an inexplicable orbital shift, a flicker of light in a rhythm, or a type of signal we haven't yet defined. That moment, if it comes, could mark the greatest turning point in human history. But it could also pass in silence. And in that silence, we would still learn something profound. Sometimes, the absence of a reply is an answer in itself. Yet whether observing or signaling, these are only the first steps. Behind the shimmering images and whispered tones, science still demands numbers. And numbers can reveal truths far colder than any imagined story. Numbers can show us that Atlas's appearance doesn't match the patterns nature usually arranges. Numbers can indicate that, within the universe's unforgiving budget, the existence of a mass like this is nearly impossible. And that is exactly what we'll explore next: the cosmic mass budget, which will cast the entire Atlas story in a new, clear, and indisputable light. When we tilt our heads to the night sky, those countless pinpricks of light give the impression that the universe is bursting with matter, that somewhere out there, massive celestial bodies must be wandering endlessly. Yet the cold, hard numbers of science tell a very different story. A story so sparse, so deliberately slow, that it sends shivers down your spine. In the vast, almost empty stretches between the stars, the density of matter is astonishingly low. It's like an immense ocean in which tiny islands occasionally emerge, just enough to surprise any wayward traveler drifting by. When astronomers do the math, they realize that at such densities, encountering a large object like Atlas in our solar system is far from a daily occurrence. The odds are so slim that on average, it would take anywhere from 1,000 to 10,000 years for a similar visitor to pass through. That means, over the entire recorded history of humanity, we shouldn't have seen even one. And yet, in less than a decade, we've welcomed 3 interstellar visitors: Oumuamua, Borisov, and now Atlas. Against the backdrop of cold mathematics, this coincidence starts to feel almost unnervingly perfect. If you imagine the universe as a vast white snowfield stretching to the horizon, interstellar objects are like tiny flowers buried in the frost. Finding one would already be remarkable. Yet we've encountered 3, each with its own color, shape, and personality. Atlas, in particular, stands out as if a brilliant branch has sprouted straight from the ice. Faced with such a sight, it's hard not to wonder, is this just random chance? Or is there something more, a hidden hand at work, or at least a truth we have yet to fully grasp? Science, of course, won't rush to label it alien mystery. Researchers quietly weigh other possibilities. They'd like the chance that we've underestimated the density of interstellar matter, that what once seemed rare might actually be far more common. Perhaps it's simply that our eyes have only recently become sharp enough to detect them, and earlier visitors slipped past unnoticed. Even with this cautious explanation, the sense of strangeness lingers, a whisper that refuses to fade. If you sit in your backyard one night, staring at the sky and imagining yourself perched on a tiny rock adrift in the cosmic sea, the isolation of Earth becomes undeniable. In that ocean, every passing ship, whether a simple wooden boat or a massive metal vessel, is a miracle. And when miracles begin to appear with unusual frequency, you start to wonder, is the ocean really as empty as we've believed? Atlas, in the way it arrived, serves as a vivid reminder of how fragile theoretical estimates can be. The 1,000 or 10,000-year calculations are neat numbers on a page, but reality paints a far more complex picture. And it's in the gap between prediction and reality that our imagination catches fire. Because if our assumptions about interstellar matter are off, then how many other truths might be hiding just beyond the veil of darkness? But the questions don't end there. If this is all just the play of numbers, we might accept that the universe has smiled upon us, showing a little more than expected. But if not, if Atlas truly doesn't belong to the natural flow, it opens a far more unsettling door. A door where we must consider the possibility that some things were placed here intentionally, with a purpose we do not yet understand. And if that's the case, the universe's mass budget, the harsh numbers scientists rely on as a reference, becomes a mirror, revealing strangeness more clearly than any conventional explanation ever could. As telescopes sweep across the night sky, night after night, we become like diligent night watchmen, listening to the universe breathe. Every photon captured, every motion measured, adds a piece to the larger cosmic puzzle humanity is slowly piecing together. Over the past decade, we have patiently widened our gaze, observing the heavens more continuously and systematically than ever before. 10 years, in the lifespan of the universe, is just a blink, yet it's a blink packed with purpose, containing billions of points of light meticulously recorded and analyzed. And yet, in that brief span, we've encountered 3 visitors from beyond our solar system, with Atlas being the third, and perhaps the strangest of them all. This string of appearances blurs the probability numbers we once trusted. If such events truly require thousands or tens of thousands of years to occur, why did we witness them within just 10 years of careful observation? The feeling is like walking through an ancient forest, where trees stretch endlessly and wild creatures hide in shadow. Legend says that to see a rare white stag, one must wander lost in the woods for centuries. But after only 10 steps, you spot not 1 but 3 white stags, each appearing in turn, each with its own distinct presence. In that moment, you wonder, is there something wrong with the books, or is this forest trying to tell you something? Atlas is such an example, an improbability so extreme that it shakes the carefully built theories of the cosmos. Scientists have approached this puzzle in 2 ways. 1, we may have underestimated the number of interstellar objects in the universe, that they are far more numerous than we imagined, only previously invisible to us. 2, Atlas may not fully obey the natural laws as we know them, and its presence in our solar system might not be a mere chance encounter. If we lean on the first explanation, we can take comfort in believing that technology has opened a new window, that our sharper eyes are simply revealing what has always been there, but unseen. But if we consider the second, the story becomes far more unsettling. It hints at the possibility that Atlas's arrival carries some intent, that it is not just an inert chunk of ice drifting through space, but a being or a structure with purpose. Sitting by a window on a quiet night, we can imagine ourselves as Earth, small and dreamy, gazing into the vast void. Every visitor, even the briefest, surprises us and thrills us like a child seeing fireworks for the first time. Yet when those fireworks come too frequently, we begin to wonder, to suspect that there might be design or a warning. Once that question surfaces, it leads us into new terrain of thought. It forces us to reconsider everything we know about matter and space, about the statistics we trust, about the models we assume are rigorous. And in that pause, we realize that the answer may not lie in the pages of our textbooks, but in a deeper realm, where science and imagination meet. By appearing at the right moment and place, Atlas has placed us at the threshold of a paradox. It reminds us that the universe doesn't always move to the rhythm we expect. Sometimes it throws us an unexpected piece, making us question whether the bigger picture is truly as we imagined. And from that anomaly, we move into another story, one of mass, a harsh, weighty number that may reveal the true nature of this extraordinary visitor. Every time the universe presents us with a paradox, the next question is always, what then is the solution? With Atlas, its strangeness puts us at a crossroads. One path is simple and familiar, suggesting that our calculations, our models of interstellar matter, are still incomplete, that our science isn't yet deep enough to grasp the full richness out there. The other path is rougher, colder, hinting that Atlas might not be entirely natural, that within it lies a hand, an intention, a mark that is unmistakably different. If we take the first path, we might imagine that the numbers humanity has been writing down for decades are only rough sketches. Perhaps the true picture of the universe is far more detailed than we can see, and Atlas is just one of countless visitors passing through, invisible to us because our vision is limited. It's like sitting by a window watching the rain, thinking only a few drops are falling, while outside a relentless, endless downpour drenches the world. From this perspective, Atlas becomes reassuring, a reminder that the universe still follows its laws. We simply haven't yet learned to see them fully. The second path chills the imagination in a different way. If Atlas isn't a natural object, then its presence in the solar system feels like a message sent to humanity, written in a language we cannot yet read. Perhaps it is a probe, massive but silent, quietly collecting data on Earth from afar. Perhaps it is a fragment of some ancient technology, drifting through space for millions of years. Or maybe it is simply a signal left behind, a question mark suspended in the dark, compelling us to confront the possibility of others out there. Thinking about these two possibilities, one cannot help but feel humbled. If our models are wrong, we must admit that human intellect, despite all its reach, is still only a few strokes on a vast cosmic canvas. If Atlas is not natural, we are forced to face the truth that we may not be alone, that a grander story is unfolding, far beyond the limits of what we know. On a night when you lie under the sky, listening to the wind whisper through the leaves, there are two ways to understand the silence around you. Either the forest sleeps, and you simply haven't noticed the creatures hiding in the shadows, or eyes somewhere in the dark are watching, and the quiet is just a veil concealing them. The universe, when we think of Atlas, gives the same feeling. And whichever path we take, one truth remains. Atlas has planted a beautiful doubt in the human heart, a drive to look deeper and a hunger to understand. It transforms science into a journey not just of numbers and data, but of imagination and attentive listening. A single object, whether natural or artificial, can compel all of humanity to look up, to wonder, and to reflect on our tiny place in the cosmos. The story pauses here, like a low, lingering note. We have pondered the natural, the artificial, and the inexplicable strangeness of Atlas. Yet one question still hovers, unanswered. Does that colossal mass, when placed within the grand cosmic picture, truly fit the universe's material budget? And if not, what truth awaits us beyond those cold, unyielding numbers? When we talk about a colossal object like Atlas, the numbers, its mass, its size, can be truly overwhelming. Imagine an icy sphere stretching for kilometers, weighing tens of billions of tons, hurtling through space at unimaginable speeds. But when scientists took a closer look, they noticed a puzzling discrepancy. Based on the light Atlas reflected and its estimated size, its mass didn't seem to add up. If it were dense and solid like a typical comet, its movements, its gas emissions, everything should have looked very different. Yet Atlas behaved oddly, almost as if its interior wasn't solid at all, but largely hollow. A bold idea emerged. What if Atlas were a hollow structure? Suddenly, the numbers became easier to grasp. Its mass would be much lower, explaining why the escaping gases didn't noticeably alter its trajectory. Its sheer size still commanded attention, but inside, it could be empty, like a massive balloon far lighter than it appears. The image evokes human-made structures, steel domes, spacecraft, hollow satellites, all reminding us that sometimes a massive exterior is just a shell, hiding a purpose-built emptiness within. Imagine floating near Atlas, seeing its icy surface glint in the distant sunlight. If you tapped lightly on it, perhaps you'd hear a hollow echo, a cold reverberation stretching across the void of space. And if it truly were hollow, one can't help but wonder why. Is this simply a rare natural phenomenon, or could it be a trace of design, evidence of some intelligent hand shaping it? The concept of hollow structures isn't entirely foreign to science. Meteors are sometimes thought to be hollow due to chemical reactions, or because volatile materials inside evaporated away. But with Atlas, the idea opens the door to something even more daring. It could be a shell, a vessel, a hollow cavity built for some purpose beyond our imagination. Consider that this object is interstellar, crossing vast distances between the stars, and the notion becomes even stranger, stirring awe and unease in equal measure. Here, science and imagination converge. One side measures, calculates mass, estimates size. The other weaves a vision where Atlas could harbor chambers, storage compartments, or even dormant devices waiting to be awakened. It's like holding an empty seashell washed ashore by the ocean. You know life once occupied it, and the void inside is the trace of what has passed. Yet, until solid evidence appears, it remains a hypothesis. Science demands caution, careful steps, a balance between the unusual and the plausible. Still, the fact that a hollow structure could resolve Atlas's inconsistencies makes it a compelling idea. At the very least, it opens a window to a different possibility, a new way of thinking, rather than getting stuck on numbers that don't quite fit. And then, when we gather all the hypotheses, from mass, composition, and trajectory to the possibility of emptiness, we return to a single moment. A fateful point where everything will be tested. October 29th, when Atlas reaches its closest approach to the sun, hidden behind the blinding glare, leaving us on Earth completely in the dark, powerless, before the events unfolding on the far side of our star. All our speculations, anxieties, and hopes converge at that instant, where its secret might finally be revealed, or continue to remain cloaked in silence. There are moments in the universe when the arrangement of celestial bodies feels like a theater curtain closing, hiding everything happening behind it. For Atlas, that moment came on October 29th, when it drew closest to the sun, while, by a cosmic coincidence, Earth sat directly on the opposite side. In that instant, we became like an audience ushered out of the theater, hearing the music from inside, but unable to see a thing on the stage. From a scientific perspective, this makes perfect sense. When an object reaches perihelion, it is swallowed by the sun's intense, blinding corona. From Earth, any attempt to observe it is futile, the light too overpowering, drowning out every faint signal we hope to detect. What makes this moment extraordinary, however, is the coincidence. Not only is Atlas obscured by the sun, but it also reaches this point when Earth is on the far side, leaving us without a single angle of observation. It doesn't just fade from view, it vanishes entirely, slipping out of humanity's gaze, as if taking advantage of a secret window to do something in silence. Now imagine you're on a hypothetical observatory on the far side of the sun, shielded from the blinding light. You would witness a strange scene. Atlas glides through partial shadow, slowing slightly under the star's massive gravitational pull, like a dancer pausing at the most crucial beat of a performance. And you, the only observer, would feel as though you're witnessing a secret hidden from the entire Earth, a private moment between an interstellar visitor and our central star. That moment invites reflection. If Atlas were just an ordinary comet, its disappearance would be nothing more than a limit of observation. But if it's something else, the scene feels like a perfect veil, a pause, a space to shift, to adjust, to hide. It raises a question that's impossible to answer. Is the universe simply teasing our curiosity? Or is this genuinely a chance that Atlas is taking? And so, with the sun's bright curtain closing us off, all we can do is wait. Wait for it to emerge on the far side, in November or December, to see whether its orbit has shifted, whether it is still itself, or has become something entirely different. All the mystery, all the anomalies converge at this single point. And from here, the story pulls us deeper into the next chapter, where real possibilities emerge. What if Atlas returns and stays in our solar system? In the long, winding journey of an interstellar object, perihelion is always a crossroads. There, the sun's gravity takes the role of conductor, orchestrating the orbital symphony it will follow from that moment onward. For Atlas, October 29th was that pivotal instant, a fragile moment in which its fate could shift. From a physics perspective, this is where all kinetic energy is put to the test. If Atlas keeps its speed, it will slip past, escaping the sun's embrace, drifting forever into the distant, dark reaches beyond the solar system. But if, in some way, it slows down, even just a little, that slight break could turn it into a new resident of our solar system. From a fleeting visitor, it could become a neighbor, tracing a path around the sun for millions of years. Imagine standing at the edge of the void, watching Atlas blaze in the sun's white-hot light. It moves like a giant bird diving into an abyss. And with just a tilt of its wings, a slight loss of speed, it could find a new trajectory, circling instead of racing past. That moment is a fateful fork. One path carries it away forever, leaving Atlas as nothing more than a fleeting name in the records. The other path keeps it near, turning it into a long-term subject of observation, a mystery that lives alongside us under the same cosmic roof. The difference between these paths stirs a quiet awe, because this isn't just the story of a chunk of ice and rock. It mirrors the choices humanity faces when confronting decisive moments. In an instant, destiny can split in two, and we have no control. All we can do is watch, silently asking ourselves, which way will Atlas go? Science, of course, does not imbue Atlas with will. If it slows, it could be the result of a naturally fine-tuned orbit or something else, deliberate. And it is that possibility of something else that quickens the observer's pulse, opening the door to imagination. In the silence of space, October 29th hangs like a suspended note. We cannot know the next melody, only that every eye is fixed on a single moment. And when Atlas disappears behind the sun, all that remains is waiting for it to reemerge on the other side, to see what changes have taken place, to learn which path fate has chosen. And in this way, when we speak of the chance to change destiny, we are not only speaking of Atlas, but of ourselves. We too stand before a moment in the history of science where every hypothesis is tested. But to know the answer, we must wait until that brilliant light unfolds and the visitor appears again. From here, the story carries us toward the next horizon, where all mysteries converge. What will happen when Atlas steps out from the sun's glow, and will we recognize that it has truly become a resident of the solar system? There are moments of silence in the universe that make us feel like we've been left alone in a dark room, waiting for a door to crack open so we can see what's happening outside. For Atlas, that silence comes after October 29th, when it slips behind the sun, vanishing from human sight. For weeks, we won't be able to observe it, measure it, or verify anything. All that remains is waiting. And sometimes, waiting is the hardest part of all. From a scientific perspective, predictions have already been made. If Atlas is just an ordinary comet, it will continue along its calculated path, disappear from view, and reemerge in late November or early December, following the same orbit as before. But if, during that unseen interval, there's even a subtle slowdown, a barely noticeable shift, then when it returns, its trajectory could be entirely different. That's when we would know it made a choice. That the solar system isn't just a place it passed through, but somewhere it intends to stay. You can imagine it like sitting on a porch, watching a stranger step into a shadowed garden. The visitor disappears behind the trees, and you have to wait until morning to see if they've left or remain hidden somewhere in the darkness. That suspense stretches every moment, letting the imagination spin countless possibilities. With Atlas, every passing day carries the same flutter of anticipation, mixed with a touch of awe and worry. By late November, all eyes will turn skyward, waiting for even the faintest glimmer of light as it emerges from the sun's glare. That moment will feel like a curtain lifting on a stage, revealing the next act of a story that was hidden from view. And no matter how Atlas appears, ordinary or unexpected, the answer it brings will be a crucial piece in humanity's quest to understand. Yet perhaps the most meaningful part of this waiting isn't in the answer itself. It's in the act of waiting. In an age where information arrives instantly, having to patiently wait weeks or months for new data reminds us that the universe isn't in a hurry. It has its own rhythm, slow, infinite, and we are merely students learning to listen. So as the year edges toward its close, that sense of anticipation becomes a gift Atlas has inadvertently given us. It makes us look up, reflect, and accept that not every question has an immediate answer. At the same time, it opens a window to the next chapter, where we try to connect all the pieces we know, searching for the biggest question of all. Is Atlas just a comet, or something else entirely, a visitor from a distant civilization? As the story of Atlas draws to a close, it feels like closing a thick, weighty book. Each page filled with surprises, strange details, and quiet moments for reflection. And as with all great books, reaching the final page does not bring a full stop. This story doesn't end here. It opens onto a vaster space where questions continue to echo. If scientists were forced to choose the most likely explanation, they would probably take the safe route. Atlas is simply an unusual comet, extraordinary, yet natural. Its puzzling features, the orbit hugging the ecliptic plane, the striking alignment of its perihelion, its enormous size and staggering mass, the backward glow, and its strange chemical composition can all be neatly labeled as unusual celestial object. In the vastness of the universe, rarity is natural, and not every oddity carries a profound message. Yet a long chain of anomalies stacked together begins to whisper insistently. It becomes difficult to look away, hard to dismiss as mere coincidence. Each detail alone might seem ordinary, but together they form a picture more like a question mark than an answer. It's like entering a room and noticing a chair slightly out of place, a window ajar, a clock stopped at the exact hour you were thinking of. Alone, these details don't compel a conclusion, but together, they make you sense an unspoken presence lingering in the air. Avi Loeb has emphasized that even a 1% chance that Atlas could be alien technology makes studying it a historic opportunity, one humanity cannot afford to miss. 1% may sound small, but on a cosmic scale, it is enough to change everything. Ignoring it, if it were indeed a trace of another civilization, would mean missing the greatest opportunity in human history, to know we are not alone. And even if it turns out to be just a comet, careful observation is never wasted. It teaches us about visitors from the far reaches of space. Science is built on caution, but it never grows without courage. It is the bravery to ask what if that has taken humanity off Earth, to the moon, and inspired dreams of journeys beyond. With Atlas, that courage is tested once more. Many may dismiss alien technology as fanciful, but the truly unscientific act is failing to consider it at all. Imagine yourself in that moment, sitting on a dark hill, gazing at a winter sky. Among millions of stars, Atlas drifts quietly, its pale green glow like a secret signal. You know it might just be a natural flare from evaporating ice, yet deep down you cannot help but wonder about another possibility. A light that is a beacon, a silent greeting from across the void. And in that very moment, when your imagination awakens, when you realize the universe still holds so much unknown, Atlas has already fulfilled its mission, to make us look up and ask. Perhaps the beauty of this story lies not in what Atlas is, but in how it makes us think about our place in the cosmos, the potential existence of other civilizations, and how humanity might respond if that day ever comes. If someday an undeniable sign appears in the night sky, proof that intelligence out there is watching us, will we tremble in silence or greet it with courage? This is why Atlas cannot be dismissed as mere coincidence. Sometimes, anomalies are history knocking at the door. Small, strange things are the universe's way of asking, "Are you ready?" As Atlas gradually slips from view behind the sun, only to reappear in the weeks ahead, we enter a period of waiting. Waiting to see whether it will remain or leave, waiting to see what its orbit will reveal. Yet at the same time, we are waiting for an even bigger answer, one not just about Atlas, but about our own existence. Perhaps the most important part of this conclusion is uncertainty. Within that uncertainty, between comet and technology, nature and artifice, chance and intention, is where human intellect grows. If the universe were fully revealed, what would remain to seek? It is questions like Atlas that make the night sky glitter, not just with light, but with wonder. So as we close this chapter, let it remain an open door. Atlas may be an unusual comet, a wandering shard of ice from the distant reaches. But maybe, just maybe, it is the first time in history we have glimpsed extraterrestrial technology crossing our skies. And if so, we are witnessing a moment as awe-inspiring as the first sight of the ocean, or the day Neil Armstrong set foot on the moon. Whatever the answer, Atlas has planted a seed within us, a seed of curiosity, imagination, and the belief that the story of life out there has never truly ended. And that seed will continue to grow, guiding us into new chapters of a grand journey. The journey to answer humanity's oldest question: are we alone in this universe?